We've just seen that there are stronger intermolecular forces in larger hydrocarbons than there are in smaller hydrocarbons. The strength of the intermolecular forces between hydrocarbon chains has a big impact on hydrocarbon properties. Firstly, a longer hydrocarbon will have a higher boiling point than a shorter hydrocarbon. The boiling point of a substance is the temperature at which it transitions from a liquid to a gas. For example, the boiling point of heptane, which is the alkane with 7 carbons, is 98 degrees Celsius. Whereas the boiling point of propane, which is the alkane with 3 carbons, is minus 42 degrees Celsius. You can clearly see that increasing the length of the hydrocarbon chain from propane to heptane has led to a significant increase in the boiling point. Propane's boiling point is below room temperature because room temperature is about 25 degrees. Therefore, propane will be a gas at room temperature. However, heptane's boiling point is above room temperature, so we'd expect it to be a liquid. And this is a typical observation, that the shorter chain hydrocarbons are gases at room temperature, and the longer chain hydrocarbons are liquids. Longer chain hydrocarbons will have greater boiling points because of the larger intermolecular forces between molecules that make them up. In order to undergo the transition from liquid to gas, we need to break some intermolecular forces in order to give the particles the additional freedom that they have in the gas that they did not have in the liquid, where they were held more closely together. Breaking these intermolecular forces takes energy, and the amount of energy it takes will depend on the strength of the intermolecular forces. If they're strong intermolecular forces, it will take more energy. This energy is in the form of heat. So if more energy is required, the boiling temperature will be higher, as more heat energy needs to be put in order to break the intermolecular forces and cause the liquid to become a gas. Therefore, it follows directly from the fact that longer hydrocarbon chains have larger intermolecular forces between them, that they have a higher boiling point. It will be easier to overcome the intermolecular forces that are holding a shorter chain together. It's easier to overcome the intermolecular forces that are holding shorter chain molecules together, and they'll boil at a lower temperature. The second property of hydrocarbons that is directly related to their chain length is how flammable they are. We generally see that shorter hydrocarbons are much more flammable than longer hydrocarbons. As we've just seen, shorter hydrocarbons will have lower boiling point.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the Snap Revise smiley face. Join me today and together let's make Chemistry at GCSE a walk in the park.